Today we're looking at the Folium library and using it with GeoPandas. Folium is a Python wrapper for the JavaScript mapping library Leaflet. In order for a wrapper library to be a success, it requires an active development team to keep up with the changes in the library it's wrapping around, which I believe Folium has. They even have wrapper functionality for popular Leaflet plugins. As of GeoPandas 0.10, mapping with Folium is built in and available on any geodata frame. The built-in capabilities don't cover every use case, and most people still aren't on this version of GeoPandas, so we'll also cover using Folium directly. We're going to make 3 maps. One visualizing the data we created in the Intro to GeoPandas video, with changes in DC's Department of Transportation construction permits from 2012 through 2021 by neighborhood cluster. A heat map of the global terrorism database, and one visualizing the leading believed causes of suicide in India in 2020. We'll start by importing GeoPandas and reading in the GeoJSON that we made in the last video. There's more columns here than are strictly necessary, so I'm going to filter some of those out so that when we visualize this on a map, we'll have fewer things to visualize. So the things that are important are the data from 2012, the data in 2021, the cluster name, the neighborhood names, the percent change, and then obviously the geometry. And we can fill any nulls with 0 just to be safe. So now that we've got a geodata frame, actually making an interactive plot with Folium is, it's actually a one-liner. Pandas has a new explore function that if we call, will immediately give us a map that we can scroll over and see all the metadata about each shape. But last time we had made a static choropleth, so we'll do the same but make it interactive. The explore function has that built in. You just specify the column. So in this case, we want it on the percent change. And we can also give this layer a name. And already we've got a map that displays the exact same information as last time, but now we can see the neighborhood names themselves, we can see the clusters, we can get the percent change as we scroll over the map. The explore function actually gives us a Folium map object back, so we can capture that in a variable. We can then use this to add additional things to our map. So one thing that I like to add is a layer control. So to do that, we can just import Folium. This is actually a function. And then if we use the m variable to display this again, we now have a layer control that allows us to turn off and on different layers. We can actually save that map object to file. So if we do m.save and give it a file name, it'll save it as HTML and JavaScript. So now we actually have an HTML file. We can open that up and we have all the elements that we created in Python. And so now you can embed this in a site or share it around or edit the HTML and JavaScript directly, whatever your end goal is. This is also really useful for just investigating the data that you have without having to export it to file and open it up in GIS. So if you have an earlier version of GeoPandas or you want to create a map directly, we can start by creating a map object. And that takes a location as a lat-long pair. So if we wanted to do DC, we can give it the center of DC. You can specify tiles, so we can actually make this map look a little bit different. and then give it a zoom to start. And if you're not familiar with zooms, they go from, I believe, 0 to 20, 0 being very zoomed out, 20 being very zoomed in. And so now we've got a capitalization is important. So now we've got a map of DC at the zoom level is centered on it, so now we can add data. So this isn't quite the choropleth that we created above. We can recreate that as well. So I'm going to scroll up here and steal this so we can initialize a new map down here. So I'm going to make a new variable, call it cpleth. We can use the Folium choropleth function. We give it our geodata frame, and it's just going to use that for its geometries. It's not actually going to get the fields from it. So if we want those in there as well, we can say the data is also equal to the geodata frame. And we have to tell it what features to key on. And we want that to be on the name. Let it know what columns are important. Specify a fill color, and this draws from matplotlib, so you can use any of the color maps there. If we add a legend, give it a legend name. We can use the same tooltip as above. And give it a name. All right, so we can add this choropleth to our map. Ah, that's right. So we actually have to add the tooltip separately. As a child here. So this actually is not necessary. We can add layer control. And this isn't necessary, but I really think that it gives users a little bit more capability. And then we can show our map. So this looks a lot like the map that we created in the Intro to GeoPandas video. But now, if we can send this around, users can interact with it a little bit and get a sense of the data that's driving it. So that's all the major functionality that we're going to cover. We are going to make 2 more maps to go a little bit more in depth and show some of the plugin capability that Folium has. But broad strokes, we've got the ability to put data on a map, specify the tooltip information, and write it out to file. So next we're going to be making a heat map using the Global Terrorism Database, which is an open source database on terrorism events around the world, ranging from 1970 to today. I downloaded this version off of Kaggle, so it's a little stale, but should be fine for making a heat map. So first we can import pandas, and this is a CSV file, so we actually don't need to use the geodata frame for what we're doing. We can go ahead and read it in. And we do need to specify the encoding for this file. Somewhere in this long list of columns, we've got a latitude and a longitude. And so we need to make a list of coordinate pairs of longitudes and latitudes in order to make a heat map. Some of the coordinates do have nulls in them, so we have to filter those out. So we can import math to do that. So we can say our coordinate list is equal to the result of our list comprehension, which is going to be lat long for lat long in our latitude and longitude columns, which we can zip together to loop over simultaneously. And we only want to grab them if they're both not null. And we end up with a coordinate list of longitudes and latitudes as tuples. And we can actually feed this into the Folium plugin for heat maps directly. So we can skip using a geodata frame completely. So Folium has a plugins that we can use. So we can say M is our Folium map. Give it a starting location as a lat long pair. Specify the tiles if we want. And give it a initial zoom. And because this is a worldwide data set, we'll start very zoomed out. So if we run this as is, I have to import Folium as well. We've got the CartoDB dark matter map as our base map, sort of a worldwide zoom. So we can call that plugins directly. Pass it our coordinate list. Add it to M, and then display M. And so now we've got our heat map, which suggests that nowhere except very cold places like Siberia or Canada, possibly Alaska, are safe. And if we zoom in, this does change in resolution. And there are a bunch of additional options for heat maps. So in this case, we can change the radius a little bit, lower it in this case. So as we zoom in, you can start to see it get a little granular, a little faster. The last map I want to make was inspired by a post I saw on Reddit that has unfortunately been deleted. They had made a map of the most commonly stated reason for someone committing suicide in India based on region. They had cited their data source, so I went and downloaded it as a PDF. And after a bunch of work converting that PDF into an Excel file and merging that Excel file with a shapefile of the regions in India, we now have something that we can work with. So I'm going to do all our imports up front. Give a variable with the file name. Then we can list out the layers that are in this G package. We've got one layer for each of the categories that the data was broken out into. So we can actually make 4 different maps and maybe put them on the same map. So let's go ahead and do that. So let's create an initial variable for our map and start it equal to none. And we're going to loop over each one of these layers, read it in, and add it to the map one by one. So when reading in a geo package, you can specify the layer. And I'm actually going to pare down the data that's getting read in. I only want data that I put in there, such as the top 5 most listed reasons for suicide, the region name, the geometry, and then the most common. And so actually, before we continue, let's take a look at that data frame. So for each region, we've got the geometry associated, the most common stated reason, and then in HTML, the list of the top 5. So we can give this layer a title. Rename the columns. Otherwise, we're going to be seeing most common across all of them. So if M is already initialized, that means we've already got a map. And you can tell the explore function what map to use using this M input. Tell it which column to use for the choropleth. Give that layer a name. If M does not already exist, then we can go ahead and create it. And we'll use the same options. And in this case, because there's 4 layers, we're definitely going to want to add layer control. This will take a minute to read in the data and add it. And so it does start with all the legends stacked on top of each other, but we can pull these apart and all the layers turned on. But we can go ahead and turn these on and off to see the different reasons that different groups state for their suicide by region. And if we scroll over, we can see not just the most common, but the top 5 most common as well, with some numbers associated. And so now this file can be saved off and either sent around or just used for some initial data exploration. If you write out this file, you'll be able to edit the JavaScript and the HTML to tell it where to actually put these so they're not stacked on top of each other, and maybe to disable some of these layers by default. Because all of these regions are pretty detailed, we can actually save a little bit of space and time by using GeoPandas' ability to simplify geometries. So right after reading it in, we can actually add a call to the GDF simplify function and give it a tolerance. In this case, we're in decimal degrees. Make it a little more detailed. And this is going to overwrite our geometry column. So again, this will take a little bit of time to run. And we're not really going to notice much of a difference in the output. But in terms of file size, if we are going to share this around, this will make a big difference. Note that the legend colors are not consistent between these layers. It is possible to specify what colors to use for which values going into each one of these for something more consistent. But that starts to get quite detailed. Really comes into play if you're going to make this an actual product. All of the code shown here will be on our GitHub, which I will link to in the description. If you have any questions, comments, or something that you'd like to see in the future, please leave a comment below. If you enjoyed this or found it useful, please consider liking the video and subscribing to this channel. Thank you for watching, and I'll see you next time.